Hey guys, just wanted to record probably one of the final videos to go over the most common mistakes from this week's lesson. So let's take a look. All right, so this first section had to do with identifying what were the products when you have a neutralization reaction, which is when an acid and a base react to form a water and salt. Now, a lot of people struggled on when to put PPT or when to put salt. PPT stands for precipitate. And that's when two things combine that aren't soluble. Like in the case of calcium hydroxide, which is this guy, plus carbonic acid. Notice that CaCO3 is insoluble, stays together, so it forms water and a precipitate. However, when we have something like HCl and NaOH, it forms a salt because NaCl is soluble and will split up and will stay dissolved. So that's the difference between salt and PPT in the first section of the assignment. A lot of people were confused on this part. H2 with acetic acid. This right here is acetic acid. That's the same thing as vinegar. And it has this formula. It also has this formula. They're the same formula. If you count up the number of C's, O's, and H's, you'll notice that it's the same. Its structure looks like this. And so when it becomes an acid, this particular H pops off and it forms H plus, and this becomes a minus, or the acetate ion. And that is in our periodic table, and the salt that it would form here, in this case, for example, would be Ca, which is a plus 2, and we would have C2H3O2, which has a charge of -1, which is what we see here. And because Ca is a plus 2 and this is a -1, we have two of these guys right here, which are formed. This is the salt when acetic acid and calcium hydroxide are formed. The name of this is calcium acetate. Let's continue on. And so here we have the last part, which had to do with titrations. And what happened here is we had a flask, and inside we'd have either an acid or a base. And we would drip in from a burette an acid or base, and we're trying to figure out what concentration it is. And we would have a volume of an acid, molarity of an acid, and we would have the volume of the base that we titrated in, but not the molarity. So point is, we would have two of these. We needed to experimentally determine in the simulation one of these and then calculate this one. And the way we would experimentally determine this is when we saw a color change. That was when the indicator would indicate whether or not we have neutralized the solution. And in all of these, what you had to do was figure out a certain volume. It could have been a base or an acid by looking at a color change. And then we use this equation to solve for the unknown concentration. For example, in the first one, we would have had 25 milliliters times, let's say it was 0.2082 molar, which would be the unit for molarity, equals, let's say they had this volume, 50.04 milliliters times an unknown concentration. Well, we would divide by 50.04, and so that cancels out because it becomes 1. So these two divided by 50.04 would give us our concentration right here. Basically, we use MABV MAVA equals MBVB.